Okay, so we just finished going over the pre-order traversal for a tree. So let's go over in order. In order is where the node is going to be visited in between the left and the right children. So we're going to start at the root like we did last time, but rather than printing out the value of that root immediately, the first thing we do on our to-do list is visit the left child. So E is not going to print yet. All right, we're starting here, but we're going to go to left first. And then B says, okay, my to-do list says go left first. So we're going to go left to A. A's to-do list says go left first, but it doesn't have a left child. So then A prints itself. And the very first letter that gets printed in this traversal, or the very first node that really gets visited in this traversal is A. So that's done, N. So then it visits its right child, but it doesn't have one, so it returns up to B, and B is now done visiting left. So now B will print itself. There we go. Now B will go to its right child. D. Left, and then self, and then right. So B goes left first to C, which doesn't have a left child, but it does print itself. And then it goes to its right child, but it doesn't have one, so it returns to D. Now D is done visiting its left child, so it prints itself, D, and then visits its right child, but it doesn't have one. And it returns to B. B is done visiting its right child, so it returns to E, and now finally E is done visiting its left child, and E gets to finally print itself. Do you notice what's happening over here? I bet you do. So now E gets to go to the right, right? And so we go to F, which goes left first, although it can't, so nothing happens. Then it prints itself, and then it goes to the right. H goes left first. G can't go left, so it prints itself, and then it goes right, which it can't do either, so it's done and it returns. Now H prints itself, and then it goes to the right, to I, which goes left first, which it can't do, so it prints itself. And then it goes right, which it can't do, so it's done, and it returns to H, which is now done going right, so it returns to F, which is now done going right, so it returns to E, which is now done going right, and then the algorithm ends. And as you can see, with in order, the output is in alphabetical order, and that is just because the tree that we're doing this on is a binary search tree. So it's already set up in such a way that the left child is less in. It comes before the node itself, which comes before the right child, and that's the case in every instance. So because the order, the alphabetical order is set up to be the same as the order in which we visit nodes in this algorithm, that's why it works out that the output prints in alphabetical order. So if you wanted this in particular, you would use this algorithm. So the last one is post order, and the post order algorithm, we're going to do left and right first and then visit the node last. So let's begin at the root. All right, first thing you have to do is go left. Go left. All right, B, first thing you have to do is go left. Oops. All right, A, you have to go left, but you can't. You have to go right, but you also can't. So finally, we get to print something. A prints itself. And it's done, and it goes back to B. B is done going left, so B goes right. First thing D has to do is go left. C can't go left or right, so C prints itself. It's done, returns to D. D goes right, but it can't. So finally, D prints itself and goes back to B. B is done with its right child, so now B prints itself and returns to E. Now E is done going left. It's done visiting its left child. So now E is not going to print itself, it's going to go to the right. F, first thing to do is go left, but it has no left child, so that's done. And now it's going to go to the right. First thing H does is go left to G. G would go left and then right, but it has neither of those children, so then it prints itself. It returns to H. H is done going left, but then it goes right. I can't go left or right, so it prints itself. It's done. It returns to H. Done going right, so now H prints itself. H returns to F, which is now done visiting its right child, so it prints itself. F returns to E, which is now done visiting its right child, so finally, a very last thing here would be E prints itself. So in a binary tree like this, when you are visiting things post-order, you'll notice the first few things we visited are leaves, right? The first are A and C. We visited leaves on the left side first, in sort of left to right order in a sense. And then we visited the nodes D and B on the way back up to the root. But then we went down the right subtree and visited the leaves, G and H, on the right subtree before visiting the other nodes in the right subtree on the way back up. And finally, the root was visited last. So in a way, it's kind of like a way, like we're going down the left and starting from the bottom and working up, and then going to the right and starting from the bottom and working up. And the root is always the last node visited in a post-order traversal. So okay, so there's a few, there are the algorithms. And what do we do in the next video? I don't know, what am I doing in the next video? Okay, the next video is an application of these algorithms to something called Polish notation.